In Euclidean geometry, a rhombus, plural rhombi or rhombuses, is a simple quadrilateral whose four sides all have the same length. Another name is equilateral quadrilateral, since equilateral means that all of its sides are equal in length. The rhombus is often called a diamond, after the diamond suit in playing cards, which resembles the projection of an octahedral diamond, or a lozenge, though the former sometimes refers specifically to a rhombus with a 60 degrees angle, and the latter sometimes refers specifically to a rhombus with a 45 degrees angle. Every rhombus is a parallelogram in a kite. A rhombus with right angles is a square. Etymology. The word rhombus comes from Greek omicron mu beta omicron sigma, meaning something that spins, which derives from the verb rho epsilon mu beta omega, meaning to turn round and round. The word was used both by Euclid and Archimedes, who used the term solid rhombus for two right circular cones sharing a common base. Characterisations. A simple quadrilateral is a rhombus if and only if it is any one of the following: a quadrilateral with four sides of equal length, a quadrilateral in which the diagonals are perpendicular and bisect each other, a quadrilateral in which each diagonal bisects two opposite interior angles, a parallelogram in which a diagonal bisects an interior angle, a parallelogram in which at least two consecutive sides are equal in length, a parallelogram in which the diagonals are perpendicular. Basic properties. Every rhombus has two diagonals connecting pairs of opposite vertices, and two pairs of parallel sides. Using congruent triangles, one can prove that the rhombus is symmetric across each of these diagonals. It follows that any rhombus has the following properties. Opposite angles of a rhombus have equal measure. The two diagonals of a rhombus are perpendicular, that is, a rhombus is an orthodiagonal quadrilateral. Its diagonals bisect opposite angles. The first property implies that every rhombus is a parallelogram. A rhombus therefore has all of the properties of a parallelogram. For example, opposite sides are parallel, adjacent angles are supplementary, the two diagonals bisect one another, any line through the midpoint bisects the area, and the sum of the squares of the sides equals the sum of the squares of the diagonals, thus denoting the common side as A and the diagonals as P and Q. In every rhombus, not every parallelogram is a rhombus, though any parallelogram with perpendicular diagonals is a rhombus. In general, any quadrilateral with perpendicular diagonals, one of which is a line of symmetry, is a kite. Every rhombus is a kite, and any quadrilateral that is both a kite and parallelogram is a rhombus. A rhombus is a tangential quadrilateral, that is, it has an inscribed circle that is tangent to all four sides. Area. As for all parallelograms, the area A of a rhombus is the product of its base and its height. The base is simply any side length A. The area can also be expressed as the base squared times the sine of any angle, or as half the product of the diagonals P, or as the semi-perimeter times the radius of the circle inscribed in the rhombus. Another way, in common with parallelograms, is to consider two adjacent sides as vectors, forming a bivector. So the area is the magnitude of the bivector, which is the determinant of the two vectors' Cartesian coordinates, r equals x1 y2 x2 y1, in radius. The in radius, denoted by r, can be expressed in terms of the diagonals P and Q has dual properties. The dual polygon of a rhombus is a rectangle. A rhombus has all sides equal, while a rectangle has all angles equal. A rhombus has opposite angles equal, while a rectangle has opposite sides equal. A rhombus has an inscribed circle, while a rectangle has a circumcircle. A rhombus has an axis of symmetry through each pair of opposite vertex angles, while a rectangle has an axis of symmetry through each pair of opposite sides. The diagonals of a rhombus intersect at equal angles, while the diagonals of a rectangle are equal in length. The figure formed by joining the midpoints of the sides of a rhombus is a rectangle and vice versa. Other properties. One of the 5 2D lattice types is the rhombic lattice, also called centered rectangular lattice. Identical rhombi can tile the 2D plane in 3 different ways, including, for the 60 degrees rhombus, the rhombular tiling. 3-dimensional analogues of a rhombus include the bipyramid and the bicone. Several polyhedra have rhombic faces, such as the rhombic dodecahedron and the trapezo-rhombic dodecahedron. As a varignon parallelogram, the varignon parallelogram of an equidiagonal quadrilateral is a rhombus. As the faces of a polyhedron, a rhombohedron is a 3-dimensional figure like a cube, except that its 6 faces are rhombi instead of squares. The rhombic dodecahedron is a convex polyhedron with 12 congruent rhombi as its faces. The rhombic triicontahedron is a convex polyhedron with 30 golden rhombi as its faces. The great rhombic triicontahedron is a non-convex isohedral, isotoxal polyhedron with 30 intersecting rhombic faces. The rhombic hexacontahedron is a stellation of the rhombic triicontahedron. It is non-convex with 60 golden rhombic faces with icosahedral symmetry. The rhombic enneacontahedron is a polyhedron composed of 90 rhombic faces, with 3, 5, or 6 rhombi meeting at each vertex. It has 60 broad rhombi and 30 slim ones. The trapezo-rhombic dodecahedron is a convex polyhedron with 6 rhombic and 6 trapezoidal faces. The rhombic icosahedron is a polyhedron composed of 20 rhombic faces, of which 3, 4, or 5 meet at each vertex. It has 10 faces on the polar axis with 10 faces following the equator.